Un momento, profesor.
Ahí está, live, ok. Ahí se está transmitiendo. Ok, sorry for that, Richard. We are transmitting this exam by streaming, yeah. Okay. Well, firstly, according to the protocol, I should announce the members of this commission, starting with Richard Schweir. He's from University of Pau in the Adour region in France. He's an external member of this commission. Then we have an internal member of this commission is Dr. Erika Rosas from our department. The co-advisor of this thesis is Faber Giraldo of University of Quindio in Colombia, and the advisor of this student is Nana Studillo. No? So we will hear the presentation of Mónica Michelle Villegas Arias. She's a student, a PhD student in our department. She will present the theme semi-automated technique of IoT quality assessment through validation and verification based on digital twins. Let me see the protocol. Okay. This is my first time as a president of this commission, as Nana Studillo knows. Nan, can you help me? Michelle has 30 minutes to her presentation.
Between 20 and 30.
Between okay. Okay, Michelle.
25 is a beautiful number.
Okay, Michelle, the protocol will be the following. Firstly, you will present us your theme during 25 minutes. After that, we will hear the question from all the members of this commission. After that, we will hear some question from the public that is attending this presentation. And after that, we will be deliberate about your presentation, about your theme. So Christian will send you and you know you to a virtual room to wait our deliberation. Okay. And this is the protocol. So you have now 25 minutes starting from now.
Okay, thank you. Good morning, everyone. I am Mónica Michelle Villegas Arias, and I'm going to present you my thesis project proposal, which is named Semi-Automated Technique for IoT Quality Assessment through Validation and Verification Based on Digital Twins. My director is Dr. Nana Studillo, and my co-director is Dr. Faber Danilo Giraldo. First, I want to explain the context of this project, which is the Internet of Things. Has a formal description of Internet of Things is that these are network of physical objects that use sensor and application programming interfaces to connect and exchange data over the Internet. The basic elements of an IoT system are first, hardware elements, second, connectivity and data processing, and third, mobile and desktop applications. In the hardware elements, we can find typically sensors and actuators, which interact with the physical world, having sensors which capture data from the signals from the physical world and use the connectivity and data processing to convert these signals into controlling signals for the actuators, which interact with the outside of the of the physical world. And finally, we have mobile and desktop applications which obtain the data and show such data to the final users and allow an interface to interact with the system between the final users and the system itself. These are the basic elements of an IoT system. This technology has been shown by Gartner as one of the emerging technologies, the most trending emerging technologies in 2019. Has one of the technologies with 5 to 10 years of peak, also with the digital twin, which I'm going to explain later. The IoT applications have been increasing over the years in applications such as military, health, agriculture, and home automation, between many others. So we can find this technology in the daily life in many devices we use, in many systems we have around. During the development, the development cycle of IoT systems, it is required the testing and quality assessment stages, mostly to validate the functional aspects of the system before deployment. This is very relevant. Why? Because many of the systems interact with the life itself, with human beings, and it is very important to validate before the deployment and avoid problems that could occur in the future. This validation has been approached by digital twins, which is a trending method for such process, for the verification and validation of systems and processes, mostly in the industrial aspects, in the industrial processes. This has been found in Industry 4.0, has one of the methods for the validation and verification processes, mostly for monitoring and analyzing the systems inside the industries. Digital twin has the description, the formal description, is a virtual model of a process, product, or service. In this case, will be the Internet of Things systems, which allows the analysis of data and monitoring of systems to detect problems before they occur. And as I shown before, is one of the trending technologies shown by Gartner in 2018. On the other hand, we have the quality on IoT systems, which is is maturing over the years. And from 2016, there was proposed 2 quality models, one by Kim and another one by Tamboto, which include some metrics and quality characteristics specifically on the IoT context. There is a difference between the quality models in the traditional quality models in software, since IoT have to consider hardware and software aspects. So these specific models proposed by Kim and Tamboto approach both aspects, hardware and software, and they define specific metrics to measure the quality for the specific characteristics. So these are some very important works that were found for the research and are going to be used for the metrics specifically inside the technique that is going to be proposed in this project. The motivation of the project is mostly because there are a few reasons which motivated me to go into this research. First, the rapid evolving and increase of the new technologies and application of IoT systems. This is because over the years have been increasing the new technologies, the embedded platforms, types of sensors, different brands of sensors, actuators, and the applications have been increasing over the daily life. So it is a very interesting field for the research. Also, the IoT systems complexity caused by larger networks of IoT devices and the integration of such technologies like hardware and software technologies. They need specific integrations, and this causes a lot more complexity since some more technologies have been increased. Also, the need of quality assessment before deployment, as I said, some of these systems interact with the life itself, with human beings, and they need to be assessed before the deployment to avoid problems and even life losses in some cases, and money losses too. And in literature, there have been reported in many works. This is one of the relevant ones in which are specified that there are still some challenges in quality and testing aspects, such as limited connections, interoperability between the systems, between all the components, hardware and software, the number of configurations that can be performed, security, integration, and many others. So this is one of the main motivations, since it shows that there is an evidence of still opportunities for research in the quality field in IoT systems. The problem surrounding this research is that there is an evident lack of techniques that allow detecting defects and problems in IoT systems during the design and development, mostly facing the new technologies, because some of the works that were found usually or typically use real devices, and this causes a high cost while performing the tests. When many devices are required, the costs get higher. And specifically, the quality aspects such as interoperability, maintainability, and portability are still maturing, are not very widely approached, since the most approached quality aspects are security, privacy. So these are some very important. There is studies that show this, that these quality aspects are very relevant for IoT systems. Interoperability, since the interconnection between the new technologies, the hardware and software technologies has required the maintainability for the system to be modified over time, and the portability to support new environments in the context of installation. Such tools that have been found in literature require, as I said, physical access to platforms or resources, making this process of quality assessment very tedious and with a high cost. I will show these works later, and they were very important for the approach that they use, but the use of physical devices are typically making or introducing high costs on the process. The research questions surrounding this project are, first, how could identical pairs or digital twins in this context of all the components of an IoT system be created and implemented supporting new hardware and software technologies? This question is very relevant since we need to have a specific technique to create the identical pairs of the system that is going to be modeled. The idea is to take all of the system and divide all of the components to create a digital twin of each of them, the connection between the networks, and find a way to support new hardware that appears over the time. This has been already approached in a proof of concept that I'm going to show later in the ongoing work, which uses the map of the technical description of the, for example, in this case, the sensors, and uses the sequences, the read and write sequences to recreate, to replicate the devices has an identical pair in a virtual context, in this case, a digital twin. The next question is, how could we combine quality specifications, requirements, and IoT systems model for the quality assessment of IoT systems? This question is very relevant also because we need to find a way to mix both the technical specifications with quality requirements and specifications for the evaluation process. So all of this must be included in the evaluation, in the model of the system. When the designer is performing all the model, must be considered what quality aspects are going to be assessed, the metrics, and some other characteristics. In the last question is, how could be defined the quality reports needed as the output of the quality assessment process in terms of interoperability, maintainability, and portability? This one is also very important because we need to define how the designer, engineer, or practitioner is going to read the outputs of the results of the evaluation process. So we need to define a way to have a human readable report from of the evaluation process using the technique and the platform supporting the technique. As previous work, there were found some relevant works, such as a method to develop digital twins for automated behavior analysis. This work specifically is very interesting because they approach the digital twin inside the IoT ecosystem. However, the difference is that they use such approach for finding anomalies in the behavior. So it's not very similar to ours in the way that the project of this proposal goes for the quality assessment of specific quality characteristics such as interoperability, maintainability, and portability. Another one is an approach to facilitate the integration, verification, and functional validation of security into devices. This one also uses modeling. Has the orchestration for the orchestration process in the simulation, but they specifically focus on the security of the devices of the system. In this case, also they don't focus on quality assessment. And a self-service or IoT toolbox to enable non-technical users to connect. This is a very interesting work, since they have a digital twin approach using a domain-specific language, a graphical domain-specific language for the modeling of the IoT system, and they allow to explore IoT data streams specifically. They don't have a quality assessment, but analysis of IoT data streams. But it is very interesting. It's an online tool, and they're open source, so it will be very interesting to compare their approach with the one that we are conducting in this research. On the other hand, there are the two works, the Kim and Tambotos, that are relevant. They propose the quality model for IoT. They don't have a specific approach for a quality assessment, but they define the metrics for measuring the quality in the IoT systems. And these metrics are very important because we are going to use in this project an homologation of both models, because both of them handle the three quality aspects that are going to be approached in this project, and is very relevant for the research itself. The IntaQT and the framework. Specifically, IntaQT uses a tool which needs physical devices, which is not, which doesn't allow an scalability in case a lot more devices are needed. So they differ in that way, that they have a mix of physical devices and virtual devices. And the framework uses, it has, they propose a framework approach. However, they don't have a tool itself. So the whole verification validation process happens manually, but they define a lot of layers, which is very relevant too, and very interesting work that we can use in the proposal. The proposal description is that this thesis proposes to use a semi-automated technique for IoT quality assessment through the system's functional validation and verification using digital twins. The digital twins are proposed to be managed through the model of the systems, of the IoT systems, and using such model, for the input of the simulation and emulation and testing orchestration process. The idea is to use such model to launch all the simulation, emulation, and testing process. This proposal is based on approaching the specific characteristics of interoperability, maintainability, and portability. And the idea is to discover defects and problems in the IoT system under assessment. These are the specificities of the proposal. Has an overview of the proposal. There have been a lot of research so far, and some proof of concepts, such as the use of AADL for the model of the systems using virtualization technologies. By now, I've been doing some tests with QEMU, but the idea is to extend with Docker and Kubernetes for the software components of the network. And the tool has been, there is already a tool that I've been working on for the proof of concept, which uses an IDL model with the hardware characteristics. An analyzer captures those characteristics and launches the simulation and emulation process. An example of the approach is first to take a system and model the system that is going to be designed, or the design system, specify the quality characteristics such as the attributes that are going to be assessed, the quality metrics, and if needed, a specification of standards or other characteristics relevant for the quality assessment. After this, the idea is to take this model for the creation and componentization of the digital twins, which creates a virtual component of each element of the system that was modeled. After this, to launch the orchestration, which includes the simulation, emulation, and testing of the system to perform the simulation and emulation of the hardware and the software that wants to be executed to, and perform the proper testing techniques related to the quality attributes specified. After all of this process, the idea is to obtain quality analysis, to perform the quality analysis and obtain the quality report. The approach is semi-automated because there is an automated stage or an automated phase that includes all this digital twin launch creation, and some of the evaluation parts have to be managed by the designer, engineer, or practitioner. So that's why it's semi-automated. The hypotheses of the project are two hypotheses specifically. The quality assessment of IoT system using the proposed semi-automatic technique increases the detection of defects during the verification and validation of the IoT systems. The same for hypothesis 1, but in the context of problems, of the detection of quality problems. So these are the two hypotheses that surround the research. For the research methodology, there are considered some engineering cycles to validate the pilot of the technique, of the implementation of the technique, since the idea is to start with a research with the state of the art, which has been already done all this time, design the technique, the selection of the technologies for the implementation of such technique, a pilot implementation, and a pre-validation. In this phase, the idea is to make the refinements to the implementation if needed, to continue with the integrations, the implementation of the technique with the refinements, a validation with a ground truth case, the analysis of the validation, and this will be in the phase 2. And in the phase 3, the idea is to test with the traditional technique, manual technique in this case, versus the proposed technique in this project. After this, to collect the data from the test, analyze the data, and validate the hypothesis. This is the research methodology for the project. The general objective of the project is to specify a semi-automated technique for IoT quality assessment through validation and verification based on digital twins, which can be used by designers, engineers, practitioners for the quality assessment in IoT systems during the design and development stages. The specific objectives are to identify and adapt the appropriate quality model and metrics for the assessing quality or in IoT, identify and extend the modeling language, design and implement a platform that supports such technique, generate quality reports from the evaluation process, design an experimental validation package, and execute the experimental validation package. These are the specific objectives. The validation for both hypotheses is divided in two, but both hypotheses have 4 steps of the validation in common, which are a ground truth case that will be used for validation, which will be designed by a group of experts, a validation using real case provided by an interested company, which is Coffee Electronics. We already have the connection with the company. Empirical evaluation by extracting IoT systems from literature review and using them as case study, and experiments using target groups for using the proposed technique versus the traditional manual only assessment. For the hypothesis 0 is the validation will be validation and experimental will compare the semi-automated technique versus manual quality assessment in search of studying the defects discovered, characteristic of the discovered defects, and quality of the output reports. And for hypothesis 1 is the same, but aiming the problems discovered, characteristic of the discovered problems, and quality of the output reports. The expected results are a semi-automatic quality assessment technique, a platform that supports the technique as a proof of concept, a publication of article in an easy journal, and publications in relevant conferences of the IoT and software engineering area. As ongoing work, we already have been working on a tool that supports the simulation and emulation process of serial devices, specifically to simulate data streams from serial devices using ADL as the modeling language and using the model of the design system as the input of the orchestration process. It's been presented in several conferences. It's been a very important work for this research. Also, some over-the-air studies have been done. Specifically, this goes on the quality characteristic of maintainability, which approaches the updatability of the systems. And some operating systems have been studied from the support that they have on the update context of the systems. Also, an over-the-air update system mechanisms taxonomy was proposed and presented. It was a publication that was presented for the over-the-air updates specifically. And a catalog of techniques over-the-air updates was also presented. So this will be used for the testing purposes of the maintainability characteristic. Has publications, there have been publications on different conferences which were presented in the IoT, cyber physical systems context, and in the simulation with the ADL. Also collaborations regarding software architecture and microservices. I participated on these collaborations. On projects participation, I had the chance to work on a research internship last year in Arias, Chile, in the IoT applied in agriculture context, in which I had the chance to participate as researcher and in the development process and deployment in a real field. Also, in a project of cyber physical systems for industry, this is specifically in Industry 4.0. I had the chance to work on this, very important for all of these research process, and the implementation of the tool that I already mentioned based on Eclipse and QEMU for the simulation and emulation of serial data flow from sensors. Some international and national events I had the chance to participate to, conferences where I presented the works that I already mentioned, and in PhD schools such as ISAPS in Leiden, University of Leiden, in which I had the chance to receive feedback from experts. It was very important also for all this process, research process. This is pretty much it. Do you have any questions?
Okay. Do you hear me well?
Yes.
Okay. Thanks, Michelle, for your presentation. Now it's the time of the members of this commission. According to the protocol, well, we are going to start with the round of questions from the commission members, and I don't know. Let's start with the geographically farthest member. In this case, is Professor Richard Schweir. Please, Professor.
Okay.
Oh, okay. Yeah.
You hear me?
Yes.
Okay, great. Thank you, Michelle, for your presentation. Pretty nice. You present well. That's good. While you were presenting, I was wondering from the beginning why you focus only on IoT. Why you are not including edge or fog computing?
Specifically, I started with physical systems, actually, but I delimited the study to IoT since physical systems are quite wide. However, I've been working on different projects on the IoT context, and I found that over this time, so many projects have appeared, and many practitioners usually implement these projects, but usually do not take the quality process very serious. I've been seeing this in several companies, and it's something that calls my attention very, very highly, because in many companies that I've been working and many that I've seen, the quality process is not like one of the stages. They only design, develop, and that's it, and they deploy. But there is not a continuous process of considering the quality aspects, or maybe to check if there is a problem before it occurs. So this is why I delimited the story to IoT, and it's one of my main interests in the research area. And mostly because of the experience that I've been having on the working process on these topics specifically.
Yes, I agree with you that there is a need for quality assessment in IoT, but not only. That's why I'm asking, and the problems are similar when you are talking about edge computing or fog computing. So also there we need some quality assessment as well. So since we are having the same problems, why you limit yourself to just IoT environment?
The idea is to.
But you can answer me, and then you say, okay, I will limit myself, and then I will see future work. But I mean, my question still sound. That's I mean.
The idea is to delimitate the IoT context, because I haven't found a specific tool or approach that considers all of the fields. So the idea is to contextualize this project in the IoT to be able to extend as a future work. That's specifically the idea, to extend, because the idea is to make the technique and the platform that supports that technique flexible to adapt some new techniques or software platforms for the testing. Maybe some designers want to use some other testing tools, and the idea is to expand the platform to support these specific cases. By now is the IoT context, because of this is the base for, I hope, a larger research in other contexts. The first proof of concept that I did was only to simulate the data streams, but for this case, the idea is to simulate a whole network, a network of components, devices, interconnections. And after this, the idea is to extend it to some other quality assessment processes, such as the ones that you mentioned.
Okay. Okay, my second question is about why digital twins?
Because there was actually
just let me explain
yes,
the flavor of my question. Since the beginning, you say, okay, I would like to use digital twins because it looks to be a nice solution. But I was wondering if you you really considered other means to do it.
Well,
it's not because your advisors, let me say, it's not because your advisors asked you or suggested to you to use the digital twins that you have to.
No, not specifically. Actually, this comes from a whole research. Previously, it was a very manual process. So I created the components, but now it is all triggered from the model. But why digital twins? There is actually a reason and the motivation specifically. I've been working on different projects, as I said, in the IoT context. And I found that there is an issue when you want to test several devices, for example. And sometimes there is a lack of physical devices. And maybe I want to test 100 sensors versus 2-3 embedded platforms, and maybe I don't have enough amount of devices. And this context is typically considered, for example, in teleworking, when the engineers are testing their products or their developments, and they don't have the enough amount of devices for testing. So the digital twins has an approach that can be replicated. If, for example, I want to, this technique, this ongoing work that I mentioned, we made tests of up to 200 sensors connected to an embedded platform. So this solves in some way this lack of physical devices that I may not have for all the processing of the evaluation process. That was mostly the inspiration about why the digital twin was used. And also because it's one of the most trending technologies. In 2018, I had the chance to go to the EXA in Spain, and we were seeing that many of the works were based on digital twins. So it's one of the technologies that have been widely used from the recent years for the analysis of the systems without requiring physical access to them. So this is basically the reason why digital twin was chosen.
Okay, I can live with it. Okay. I didn't see, you were talking about security and privacy problems, but I didn't see that in your research questions. Why is that?
Yes, because, well, there are many quality characteristics, and maybe approaching all of them will require a lot of years for the research. And while making the research from the state of the art, I found that the aspects of security and privacy have been already mature a lot, are one of the mainly approached quality characteristics. But in some works, some reports in literature have been exposed that there are some other quality aspects, in this case, the interoperability, maintainability, and portability, haven't been considered that many, in many works, haven't matured enough So I'm interested in this. For example, the maintainability. In the study of the operating systems that was made, that I shown, we created a study from a classification from the operating system that support the updatability characteristic. And we saw that there are not so many operating systems that support it. For example, the over-the-air updates. And in so many cases, it is a very important characteristic that the system should exhibit. And the thing is that the practitioners have to develop these specific components of the system, but sometimes some mechanisms are not considered. So that's why I wanted to focus on these aspects that haven't been mature, but are still open for research. And security and privacy are already considered in many works. So I delimited because of all of this research to only these three aspects, quality aspects.
I think that interoperability also has been explored pretty well in the literature, if you really want to be honest about existing works. But I understand the choice that you would like to do. Okay, no problem with that. When I look at your framework, I see and observe that you want to provide some quality assessment related to the system.
Yes.
System as a whole. But what I don't see is how you will consider the context of the system. Like imagine if you have a system in a hospital, the same system in a commercial mall won't provide the same assessment. So since this I didn't see in your ideas how you are willing to do that. I would like to know what are your feelings about it.
Yes, that specific part with the domain is intended to be specified on the model. The idea is to extend the language to support quality characteristics, and the idea is to include a context characteristics in this part of the modeling.
Where you want to include it? Where?
In the model, in the description of the model. In this case, I am using ADL, which is a description. I don't know if you have heard of it. It is a description language, an architecture description language, and I can specify on one hand all of the technical aspects, but I can extend it to support some other characteristics that I'm going to use in the study. So the idea is to specify in that extension characteristics related to the quality assessment and to the context. For example, I want to, it's not the same, of course, if I'm going to design a system for home automation versus a system for agriculture. So the parameters can change. And this can be approached by specifying, for example, characteristics such as battery consumption, this kind of characteristics, or the distance between the devices. And in the quality assessment, the idea is to take all of these characteristics and make the comparisons required for the process. That's pretty much how I think to approach that part, a specific part of the context.
Well, when I listen to you, I see that you have some ideas, but I think that it would be better that you include that in your study to make it clearer. Because I think that you confuse, at least to the best of my knowledge, between injecting more description about the application domain and the meaning of what I am observing. I'm going to give you an example. If you are observing a temperature in a smart home, it has nothing to do with the temperature in an oven if you are producing something for an industry. So you are using the same observation in both cases, but you are not observing the same thing, because in a home, the temperature means something, and in an oven, when you are leading it for an energy, it is something else. So what I'm saying is that in a way or another, you will need, if you want to provide a real quality assessment measures, you need to include semantics. And this is something you say nothing about. And I think this is a big challenge that you should be considering in your work, how you will include semantics in your framework.
Yes, of course. I think I didn't mention this on the document, but this is going to be this is actually approached already in the language, in the extension of the language. What I have to describe is the specific semantics of this extension, which is one of the stages of the extension of the language, but it is already extended in a semantic way, because by default, it doesn't support many characteristics, such as the quality specifications. So yes, I have to, I should have shown some of this part on the document, but the semantic is being approached inside the model. And there is an analyzer, a based analyzer on the proof of concept that analyzes this description and converts it to, in this case, in the simulation process. But in this case that you specifically say, it will be on the analysis of the system, of the quality assessment for a specific domain. And yes, there have to be a semantic, which is in the design or the extension of the language specifically.
So it means that you will have probably a dedicated measure for semantics.
Yes, it is inside the stage of the extension of the language, because it is already supporting, for example, characteristics of the image of the emulator, characteristics of the, for example, the periodicity of the data, the type of random data algorithm that is going to be used. This is specified in the extension, which is not supported by default on the language. But in this case, for this project, is going to be extended again for quality aspects, quality and domain aspects that are going to be used in the whole orchestration process.
And how you will reason on semantics?
I don't understand.
Yeah, how you will need to measure maybe similarity between two concepts or two descriptions. How are you gonna do that?
Specifying the specific characteristics, such as the domain, such as the distances, the technologies approach in the design. For example, it wouldn't be the same to use a Wi-Fi network than using a LoRa network in the agriculture. So the idea is to specify these characteristics inside the domain to analyze, for example, in the portability, if the system is going to be moved from an environment where there is a specific domain to another environment, and use some other environment characteristics. That's pretty much the idea that I have for approaching this. And mostly it will be for the portability characteristic, because interoperability is mostly focused on the system itself, and the maintainability is also considered on the system itself, but the portability could be considered in a different environment. And that is when the context could be important for the measurement.
Mm-hmm. Okay. I know I was long. Maybe I have other questions, but I would like maybe to leave others ask you other questions. Thank you, Michelle.
Okay.
Okay. Well, thanks, Professor Faria, for your questions, and Michelle for your answers, of course. Now, I don't know, Nan, can you help me again, please? Now is the turn of, I don't know, as
Erika.
Professor Faber Giraldi's co-advisor, so is the turn of Erika. Please, Erika, go ahead, please.
Thank you, Mauricio. You hear me well?
Yes.
Yes.
Okay. Thank you, Michelle, for your presentation and the answer you already gave, because you already responded my questions. I only have a couple of questions left. First, about your hypothesis, you want to increase increase the number of defects that you found in the systems. So I want you to explain a little more about the ground truth that you are considering, or the works that you want to compare your work with.
Okay. Well, the idea is to, with the help of an expert or of a team of experts in the IoT context, the idea is to define a ground truth case using a real case. We can use, the idea is to use one case proposed by a company, the interested company, or one used from found in literature. Use the real case, specify all the model of the system of such case, define the real problems and defects that could be on this system, and define the specific quality measurements that could be found from the inspection of the system, and have this case has the input for the validation process. That's pretty much the idea, to define with the help of a group of experts of a case.
The experts are the people from the enterprise.
Yes, both. There are both two options, from an enterprise, or there is also contact with a group of experts from a research team in India, France. So the idea is to use with both teams, which one could be more suitable for the project, but there is the expert team for such a purpose.
Are you going to choose one, or are you're going to take both? I didn't understand that part.
The idea is to the expert team from the group from India, France. However, there is also a validation process using the real company, the company with a real case. There are two validations here. There are first the ground truth case and the validation using the real case provided by the interested company. Both.
How long do you think it will take to do one or the other? I am asking you because I saw your working plan, and you are expected to finish in the middle of 2022. So my questions are around how are you going to manage your time? How much this is going to take of your planning?
This is very much considered in 1 month, because both can be performed in parallel, since on one hand we can work with the interested company, and in the other hand with the group of experts for the ground truth case.
Okay, and how big are the IoT systems this company has, for example?
The company doesn't handle larger amounts of devices.
Do you have a number?
But the idea of cases, they use embedded platforms and sensors for these purposes, but they're up to 10 or 20 sensors in each network. That's pretty much the amount of devices that could be used with the interested company. The ground truth could be larger, because the idea is to to check how much the platform could support, and have a specification after implementing the platform in this context of characteristics that could support.
Okay. You are working with a simulator, that one.
Yes. Yes.
You build it from scratch. You started from previous work. Can you talk a little bit about that?
Yes, this has been a project that I've been working in the research context from all these years. And I made it actually, it is not from scratch, the modeling part, but the simulation, I made the simulation. The language is AADL, which allows to model several physical systems and many devices, protocols, connections. Not all of them, they have an open community, of course, that extended all the time, but they have an ecosystem, which is OSATE 2, which is based in Eclipse. It is the platform that supports the ADL language. And it is a text DSL, which converts the text into a graphic DSL. I use the text modeling. I am showing here the graphic, but it is in reality, it is text as a text model. And what I developed was a plugin for OSATE 2, for the Eclipse of OSATE 2, which it is deployed from a button in the Eclipse platform, and receives the model, the description model. It has input. I perform the execute generation, and behind all of this graphical part, the execute generation, what it does is to create some scripts that launch the simulation process. So when the execute simulation button is pressed, the QEMU emulator is launched, and inside that QEMU emulator, it is simulated all the devices that are modeled. So for example, I modeled 20 sensors. They are serial sensors, specifically are for serial data streams. And the interfaces it runs Raspbian, which is a Linux-based operating system, and it creates the file system for the interfaces, in this case serial, and the data is received inside the embedded platform. The embedded platform is emulated with the QEMU emulator. And this data that I show in the black square is the data received from the simulated sensors, like if they were connected physically to the embedded platform. So I can modify everything. I can modify the data stream if a MAC address is included. For example, here, I use some specific data, the MAC address, an ending data. Also, algorithms for random data can be included inside the simulation, and it can be extended. So that's why this is a very important and relevant work for the base of all this process, because somehow this is the approach of the digital twin that is intended to be implemented. The idea for the digital twin is to map the technical description, the technical characteristics of the devices, and map them, has the sequences for read and write operations, and being able to simulate them inside the emulators. So for example, if there are 5 embedded platforms, the idea is to connect to those platforms the appropriate sensors regarding the model, and recognize everything inside. It can be extended to use not only serial, but I2C, SPI, USB. So that's pretty much what was done in this simulator system.
Do you think this is the main part that it will take you more time to in the rest of your work?
Yes, pretty much, yes, because on one hand, as Professor Richard said, there has to be a semantic part for the description of quality aspects. So these quality aspects have to be included in the extension of the language and modify the analyzer that is going to take all of these characteristics and convert them into tests or specifications on the quality assessment or other purposes. So that's very much the part, but this is a relevant work because it is already a very a big work that I've been working on for these years, and that is working. It has been already presented in some conferences for the simulation of serial data specifically, but it is already an ongoing work that is very important on this research process.
Thank you. I want to show you I want to see your methodology. You had some picture there.
Yes.
This methodology you created is ad hoc for your work, or you are inspired in another work?
No, actually, I created this methodology based on the fact that it's going to be a technique, and it requires some steps of an engineering cycle to validate the implementation of the pilot with versus the technique. So the idea of the platform is to support the technique and to make the refinements in between in pre-validations of the implementation itself. And that's why I divided the research methodology in 3 phases for all the design and implementation, for the analysis of the technique, and the final validation of the hypothesis.
Okay, thank you, Michelle. We don't have more questions.
Okay, thanks, Eric and Michelle again. Now is the turn of Professor G. What is Fabio Giraldo.
Thank you, Professor Mauricio. Nice to meet Professor Erica. I am only to say that with the participation of Professor from the University of Pau, I see some interesting challenges for the research of Michelle. For example, the modeling of semantic. This is a very, very nice question. We believe that we can manage the semantic by using a previous approach, such as a quality evaluation framework, in which the application domain is necessary for defining some key functionalities and key features of the modeling effort. Maybe Michelle, you must enforce your discourse about digital twins, because digital twins is like a conceptual representation, conceptual models of IoT systems. For us, the digital twin concept is very, very interesting, because the last 2 years in the main conference about conceptual modeling, such as VR models, and so we see some specific workshops and events about digital twins in the context of conceptual representation, concept modeling. And a lot of works inside these events are IoT systems. And I see that Michelle has a very nice problem to solve, the frontier problem around fog computing, net computing, IoT system. I see that Michelle must clarify this aspect. Thank you, Professor Mauricio. This is all my intervention. I like to listen to Comandante Astudillo.
Okay, thank you, Professor Giraldo. Okay, finally, it's the turn of the advisor, Professor Astudillo. Go ahead, please.
Thank you. I didn't realize yes, it was my minute now. Well, I don't have many questions. I do have more statement than any other thing. Just a couple of observations. One is that clearly one could guess that this line of work, line of thought, could apply beyond IoT. Definitely, as Richard says so well, edge and fog are natural candidates. So it could be some kind of scale up that can be easily guessed. Doesn't need to be proposed, but certainly can be guessed. And of course, semantics is one of the issues that keep coming back. Now, it's all over this place, because one of the key elements of Michel's proposal is to use AADL, which is a architectural description language, which are actual languages with semantics and all those denotational operational properties, and do encapsulate and hide a lot of semantics. So there are really interesting avenues of extension of that work that maybe we can touch at some point. But I do wanted to make a couple of comments. One of them about the plan, which I think is the next slide.
Yes.
That one. That I said this, but it's probably anyway good to repeat it. I as a software engineering professor, I see this and I get nervous, because in my experience, nothing complicated can be done in sequentially or in a waterfall manner. And there are a few things more complicated than a PhD thesis. So I would guess that some kind of iteration would be probably made more visible here. It's one of the things that was probably important to mention. And other than that, I don't have any other questions. I do appreciate all the very good questions that were formulated by our external reviewers. Thank you very much.
Can I add something, if you allow me? Because, okay,
Of course,
this is my first time.
Go ahead, Richard.
Yeah, just because I was looking at the plan, and I had the last question concerning validation. I think that you really maybe one of the critical issues in your work here will be validation. How you will validate your work, and I think that you will need more time to conduct the validation. The most tricky and complex thing is to create the grounded truth. And sometimes we waste like 6 months to set up our ground truth if we really want to do things properly. So yeah, I think that you have to think that twice and maybe give yourself more time about it.
Okay.
That's the only thing. Thank you.
Thank you.
Maybe 2 iterations in order to have more time for the validation, Michelle.
Okay. Yes, I'm going to consider that. Thank you for the observation.
I was muted, sorry. Okay. Well, let me see. According to protocol, the public can now ask questions. Please, if you have questions, let's see if there are questions on the streaming. I don't see any question here. No questions at all. Well, I think that we can stop here. Let me see here. I have a question. Oh, no, sorry, nothing. Michelle, we are going to ask to you to wait for us for a while in a virtual room.
Okay.
we will evaluate your presentation of the qualification exam, and after the deliberation, we will call you again, okay?
Okay. So-
Christian, Christian, please, can you stop the streaming during the deliberation and send, perdón, Christian,
Ok.
por
Ok.
favor,
Moment.
si pueden mandar a la alumna Michelle a la sala de espera mientras tanto.
¿Me
Y-
salgo de una vez o?
No, te van a dejar a ti en